This is a short video to supplement the lesson on solving systems of equations. The focus of this video will be on the applications of solving systems. In particular, let's look at an application involving a mixture problem. So in our example, we're told that a 10% solution is to be mixed with a 40% solution in order to get 300 liters of a 20% solution. The questions for us are how many liters of the 10% solution are needed and how many liters of the 40% solution are needed. So I'm going to just start this off by drawing a little visual before I dive into writing some equations. Obviously, we know the goal is to write a system that models this application, but we're really mixing two types of solution to get a new solution. So these are my buckets, so my mixtures. Please humor my drawing. And one thing I know right away is one solution is a 10% solution. Another solution is 40%. And the end product, when you mix these two together, will be a 20% solution. So I'm just going to kind of put that information on my visual here. Now I also know a little bit about volume. In particular, I know the mixture, the end result, will have a volume of 300 liters, but I don't know how many liters of 10% I need to use. So one of the questions for us was how many liters of the 10% solution are needed. So how about we use X to represent the number of liters of 10% solution, because that's one of our unknowns in this problem. Similarly, we're being asked how many liters of the 40% solution are needed. So that's my second unknown, so I'll just define that to be Y. So Y is the liters of the 40% solution. To write our systems of equations, our system here, the first equation will be the simple equation, I'll just let it be the easy one, which would be that X plus Y is equal to 300. And if I go back to the diagram on the previous page, that's really basically just grabbing that bottom part of our visual. So it's accounting for the volumes, X plus Y equals 300. I like to call that the easy equation. Then the second equation is a little harder. It's going to involve the percentages. So the first percentage was 10%. That was for our first bucket. And then the second percentage was 40%. That was for our second bucket. And in the end, the mixture had a 20%. Volume was, again there, 300. Okay, so there's our system of equations for this application. So back to our diagram, the first equation I just took the easy stuff along the bottom from the volume. The second equation we're really involving the percentage of the solutions. At this point you can solve by whatever method is most comfortable for you, whether that ends up being substitution or elimination. Neither is too hard in this case. So I'll just go ahead and rewrite our system on the next page, and then I'll show solving by elimination for this video, and then you're welcome to use substitution on your own. So here is our system rewritten. I got rid of all my crazy colors here. So again, our first equation was just X plus Y equals 300. Our second equation was 10% times X plus 40% times Y equals 20% times 300. And 20% of 300 is just 60. So if I'm solving by elimination, I'm going to go ahead and eliminate the variable X in this case. And I can do that if I multiply the top equation through by negative 0.10. And then I'll clean that up. So my new first equation looks like negative 0.10x minus 0.10y equals now to a negative 30. And I'll just carry down my original second equation, no change needed there. And the elimination method says add them up and we intentionally made it so that x is eliminated. So when we add up our two equations, our x's eliminate. Negative 0.10y added with 0.40y sounds like we really have 0.30y, or really just 3/10 y. And this is equal now to just 30. So if we divide both sides by 0.30, we will have a solution for y. So in this case, we can see that when we do our division, y will equal to 100. And if we find x, probably a nice place to go ahead and plug back in to find x would be to run back to our original first equation. I'm kind of looking at this one here. This one said that x plus y is 300. So now I can say that x plus 100, our new value for y, what we just solved for, is equal to 300. So subtracting 100 from both sides shows us that x is equal to 200. And anytime you're solving an application, sorry, I'm trying to be a little helpful with the colors here. Anytime you're trying to solve an application, there's meaning to your answer. So we need to interpret what a solution of 200 for x means and what a solution of 100 for y means. Well, we had defined x to be the number of liters of the 10% solution. Similarly, we had defined y to be the number of liters of 40% solution. So, in the end here, if I were to write what we just found, you would need, we just said 200 liters, so 200 liters of the 10% solution, and 100 liters, that was the value for y, of the 40% solution, in order to get 300 liters of a 20% solution. So that's the interpretation of what we just found. Again, the value of x came out as 200. That represented 200 liters. The value of y came out as 100 liters. So, hopefully that helps a little bit. Remember that little diagram at the beginning is always useful for a mixture problem, and I hope you get to practice.